Excellent. Hi, everyone, and welcome to today's Cisco Tech Advantage webinar. I am Janelle Krakke, and today our topic is very exciting. It's about steps to scale the Internet of Things. We've had over 200 people register for this event, so it's a really exciting topic. Our speaker today is Rafael Maranon, and he will be presenting to you today. Go ahead and go to the next slide. So without further ado, I would like to introduce you to our speaker today. We have Rafael Maranon, who is a Senior Product Manager here at Cisco, and we have a great set of 4 panelists supporting him today. We have Mitesh, Clara, Mark, and Felix on the line. They'll be answering your questions through the Q&A panel. So go ahead, Rafael, take it away.
Thank you very much, Janelle.
You bet.
Hi, everybody. Thank you for joining this webinar today. My name is Rafael Maranon. I'm a product manager for the Internet of Things at Cisco Networking Software Group. And today I will talk about how to scale the Internet of Things in a dimension that we've never seen before. My expectation for this webinar is you to understand basic steps to scale the Internet of Things in a sustainable manner. I will cover an introduction to the IoT. Then I will go to see some business opportunities, and then some challenges to capture those opportunities, and finally some solutions that we are proposing. So let's go ahead and see what is the Internet of Things. In the year 1984, there were 1,000 devices already connected to the Internet. And people at that time, they said that it will connect every person in the world to each other. And that would change the way that we live. And actually, this is what exactly happened. In 2012, there were already 12 billion devices already connected to the Internet. That means more than almost 2 devices per person in the world. Now, today, we predict that in 2020, more than 50 billion devices will be connected to the Internet. But not only to connect people, we will connect also things. Cars, trains, factories, smart meters, and also sensors. And now we can say again that this will change the way we live. But it will not only change the way we live, but actually we also change the way that we work. In 2020 will be jobs that we don't even think about it today. And we can take as a reference back in 2004, students, they didn't know that today they were going to be working as a social media manager or search engine optimization specialist. They didn't know that. However, those jobs today are in the top 10 list of more desired jobs. But beside the job, also the world will become very much digitalized. By 2020, according to a research by IDC, there will be more than 40 zettabytes of data. Most of this data will come mainly from entertainment and also from video surveillance, and a small part from the smartphones and tablets and healthcare. But this is a huge amount of data. The world will become more digitalized, the physical world. So what does it mean, 50 billion devices, new jobs, and also this amount of data? What does it mean to you? Basically, this means to you that, for example, healthcare will be more cost efficient and provide more quality to more people. And if you have to connect something to the Internet, probably, in my case, I will connect the more value thing in my life, which is my body, right? So I'm still struggling to understand why today we still need to get the car to get to the doctor office to check my blood pressure, right? That can be done through internet, right? But no, it's not only the healthcare. We are talking about energy. My building will learn about how I'm gonna be what my energy consumption behavior, and actually will optimize the whole consume. And the energy is a natural resource, so we need to take care of this. Also because the population is still growing. But besides energy, other natural resources is actually water. Now we will understand what is the leak, so we make sure that we don't lose this very precious natural resource. And the food is the same thing. We want to see where this food got spoiled in the food supply chain from the farm to my plate. So we provide more quality. We have to use less chemical to produce them, and we provide food to more people. So this is what Internet of Things actually enables. Also, we will drive safer, and also we will walk safer as well, and we will enjoy our trips. If you see the city of Sao Paulo in Brazil, there is an average of between 2 and 3 hours of commute time. So my question is, do you want to spend 4 years of your life stuck in a traffic jam? No. The answer is no. We want to actually improve. We want to make our world more connected so we solve those kind of challenges. But, the bad news is that there is still a long way to go. Only 1% of the world is connected. So we have still a lot of work to do. But the good news is that there is a business opportunity here. And if you see here, this is in this table, you can see how this is a study from GE where they show a sample of how the Internet of Things actually can have an impact on some segments and industries. And they see that for the next 15 years, if we improve only 1% the operations on those industries, we will save $276 billion. So this is a good business opportunity here. So, all type of engineers have been helping since the first industrial revolution, have been helping those industries. But now it's our turn for the Internet engineers to contribute. We have a unique historical opportunity to help to solve world challenges. And this is very exciting, actually, be able to participate on those physical world real challenges. So what we did at Cisco is just, we took this as a sample, and we say, okay, let's see how is the value, the impact in the economy for the next 10 years for all the segments and all the industry. And we built bottom-up 61 use cases, and this is the number that we got. You are probably familiar with this number, $19 trillion economy impact for the next decade. And if you analyze this number, it's $1.9 trillion per year, and this is kind of the GDP of a country like Canada. But 1.9 trillion, what does it mean? There is a study from McKinsey Consulting, and they analyzed in the year 2009 the traditional internet, the existing internet that we have today that connects people, actually in 2009 make an impact of $1.6 trillion. If the internet would be a sector would be larger than the agriculture or the energy. So this number makes sense. But what I want you to keep in mind from this number is how breakdown. So we see what are the problems that we're trying to solve, and what are the industry that will capture most of the value. So let me show you here, for example, for the private sector, where the money is. Most of the money is saving costs, improving operations by increasing the productivity of the employee, by knowing where are the assets, where are my machine, my robots, my trucks. So you know where are things, and you can monitor and improve the maintenance. Also by improving the communication between different entities in a supply chain. But also besides the saving costs, it's also generating more revenue, more customers, more revenue per customer by having more innovation, by using those sensors to get data to see how they think and improve the customer experience. So this is where the money would be in terms of what problem we're solving, but also what industries. Okay, here we have a few bubbles, and the size of the bubble gives us an idea of how which industry will capture more value from the IoT implementation. And we see that manufacturing is one of the biggest ones. Actually, you can see in the horizontal X, we can see the industry size, and also on the vertical X, we see the degree of impact of the IoT. So manufacturing is the first one, and then we have retail, finance, and information services. So those are the area where we think that the could capture most of the value of the implementing Internet of Things. Now I will walk you through different use cases so you can have an idea of how does IoT help those industries specifically. But before, let me launch the poll question here. Let me stop for a minute so we can make more interactive this webinar. So you have a window on your right, so you can select the answer for this. I will give you a minute.
Great, thanks, Rafael. Yes, the poll question should appear. You can go ahead and select your answer. Perfect. Yep, everyone's casting their vote. Exciting to see. 10 more seconds left, and then we'll close out the poll, Rafael.
Oh, great, Janelle. Thank you.
You bet. Perfect. There we go. Thank you.
Thank you, Janelle. So do we have the results from the poll here? Just take a very quick look here.
We do. Yep, it's actually just closing up here. Let me go ahead and share those poll results. There we go.
Great. Okay, nice. Okay, so we have more than 1 million devices. This is very interesting, actually. If you see an enterprise deployment like phones, laptop, printers, and servers, we may have between, 10K could be the average, but this is very interesting. So we envision that this is going to be huge. Okay, so let's continue here. Let's go back to the use cases. And from the use cases to see how the impact on this opportunity, let's just start exploring actually retail. In the retail, what the more matter for them is just, as we said before, reducing cost and improving the customer experience so they can capture more customers. Here, in order to reduce store operational costs, what they really need actually is anticipate things. Like, for example, how many counters I will need the next 30 minutes. You just put sensor on the parking lot, and you analyze the flow of the people parking, going to the store, walking on the aisle. So you see what's going on. Also, you can understand what people need by now where they concentrate in the part of the store. So you can send somebody to answer some questions. You can see how the products are consumed, so you can actually avoid out of stock situation. But this is only for one store. No, but you have a few thousand of sensors in a store. You can manage pretty well. But what about if you have more than 100 mega stores across the country? How do you want to manage this? How are you going to correlate the data? So this is you need to think holistically in order to solve this problem. If we go to another use case like manufacturer, okay, so they also want to actually improve efficiency, but more important, they want to increase flexibility of the production because customers today, they are more demanding and they want something quickly, and the demand changes so quick, it's unpredictable. So they want to be flexible and produce depending on demand. And the Internet of Things will allow them to understand if they have to produce in one plant floor, in another one. So this flexibility allows them to get to the market quickly. At the same time, they want to stay competitive, so they want to improve their productivity. Imagine that we have not only one plant floor, but we have 50 distributed across the world, and then those 50 plant floor are producing products that are distributed by hundreds of trucks to thousands of stores or vending machines and consumed by millions of users. You want to provide the same quality of experience for every one of them with your products. So Internet of Things help here in order to coordinate, to orchestrate all these systems. So we need system level view again to understand how this is going to impact and how this is going to be integrated with my existing IT infrastructure. Public sector is the same thing. In public sector, for example, in the street lighting, some cities are spending almost 30% the electricity budget. So, and sometimes you don't need a guy going every night with a car, drive a car on the street just to see with the lights broken, right? This can be automated, and actually you can do the same thing for other areas like smart parking, waste management. Many things can be automated, and also increase the safety of the city by having the video surveillance. So normally City Hall they don't want to manage this infrastructure, so some operator will take care of them, but some operator will take care of all the service in one city and also in several cities. So how do you create this large system so you can manage such an infrastructure? So this is actually what we're going to see, but there is some challenges here. Let's go to the challenge in order to build this infrastructure. But before, let me do one more pull question to see how you think about how the IoT infrastructure will be deployed. Something that will be from scratch, or something that we will add sensor to our existing IT infrastructure. So this is if you have 1 minute to answer this question, so I will let you.
That's great. Yep. Thanks, Rafael. Poll has been opened. There's 40 seconds just about or so left to cast your vote.
Thank you. Okay, great. So we have 47% of brownfield, and that makes sense. Actually, this is what we are anticipating. Some will be green deployment, but actually, if you are a large organization and you have already your IT infrastructure that connects people and people to servers to data, so what you want to do is just collect the data from the sensor and insert into your business process, so you get more data, more information, so you make better decisions. So that makes sense. So the challenge would be that if we are using our existing infrastructure to collect more than 1 million of sensors, that would be a challenge. It would be a challenge because it's going to be hard to scale, because the existing infrastructure actually was not designed for connecting 1 million of sensors. Was designed to connect a few thousand of phones, printer, laptops, servers, and some other things. Normally, most of the things that we are connecting today, there is a person behind all those devices. So if you have any problem, you can call to the IT services, support, or you can do some kind of action authenticated. But today, we are deploying sensor on the street, on the field, on the physical world, and we are connecting them across the world. So, and those devices are not just a laptop running a type of operating system. We are talking about small, tiny devices with low battery, low bandwidth to transmit in remote areas. And they are, for many vendors, they are very much segmented. So including this on an existing infrastructure will be very painful. And actually, we may have, we don't have this flexibility in order to accommodate them. So we need to make sure that our infrastructure is ready for this large scale system. Also, at the same time, we need to get the insight from those millions of sensors connected, and be able to track what is happening in the real world, in the physical world. So in order to improve the prediction, this part is not quite yet ready in our existing infrastructure. And then finally, the security is always it's a big thing. And that time more, because we have protected devices connecting, sending us data to our existing infrastructure. We may want to stop some threats before reaching out the infrastructure. So this is something that we need to consider. So with those challenges and all those business opportunities that we have, how are we going to actually solve this problem? Okay, so if we want to enable this massive scale Internet of Things, actually we need something that we need a system approach here. We need to think holistically, and this is what we call the Internet of Everything. It's not only just connecting those robots, those machines. It's actually integrating those sensors with our existing infrastructure in the mobile or cloud, and also our analytics. It's all together: people, processes, data, and things, in order to be more agile, more predictive. So this is what we're trying to achieve today. And actually, these are basic steps that will help us in this process. The steps is making our infrastructure more simple, removing complexity, so we have the ability actually to stay competitive, so our sensor doesn't consume our complete IoT budget. Also, we want to help provide some software-based agility, some holistic security, and finally making easy to adopt. As any other new technology, the adoption level needs to be very quick, so we actually reach out to all the use cases. But let me break down this into this different area. How we make simple our infrastructure. So first of all, we need our network infrastructure need to be programmable. We need to open our infrastructure so the application and the developer have the flexibility to interact quickly with our network and change those configuration automatically. Also, we need orchestration between all the different area and locations and type of devices. And finally, we need virtualization. Sometimes our sensor will give us an idea about a new business opportunity. However, we cannot build an infrastructure just to prototype, right? We cannot do something for a business that can last only 1 year. So we need to be able to accommodate those capacity that we are creating for other business cases. So we need to have this flexibility, maybe put those capacity on a public cloud, and then when the business is consolidated, moving back to the private cloud. So the physical and the virtual world need to melt in that case. So we can actually we can deploy and provision millions of sensors in a month, something that the business will require, rather than what we are doing today of deploying laptops and smartphones. Also, we need to use the analytics part to understand how things are changing dynamically, and those analytics need to be captured, and we need to provide some application centricity. So we need to be able, our infrastructure need to be looked not from bottom up, but actually from top, from the application level, according to the needs. Every company will have the developer team in-house, and they want to be able to control those sensor networks. At the same time, the security is a key part, and we have to provide that visibility that they'll let them know what's going on in their infrastructure and be able to automate, so we identify and mitigate threats dynamically in real time. So in other words, we need actually learning infrastructure in order to enable this scale. We need the infrastructure fix themselves. So we can worry about our business and not about our network. There is one more challenge here that I didn't mention before, and that actually is the diversity and the segmentation of the physical world. We have sensor camera, we have cars, all type of sensors, and how we're going to manage those entities that they are not virtual. They have their own challenges because they come from the hardware, from the physical world. So in that case, all the segmentation creates several challenges. One of the solutions that we propose in order to solve this segmentation is actually partnering with the subject matter experts. We need help. We don't understand those industries. They have been creating 100 years ago. They have thousands of standards. We don't understand that, and it's going to take us a couple of decades to learn those things in order to integrate with our existing IT infrastructure. So we need to partner with them. We need to learn from them. We need to work together in order to see how we're going to accommodate the legacy infrastructure so they can join the Internet, because they want to be in Internet as well. We can build the Internet of Things only for some of the devices, but we will be missing a historical opportunity to translate the whole physical world to the Internet. So I think it's better to wait for them so they can catch up, they can translate their protocol with the internet. So we go all together. This is very important for adoption level, and we need that expertise. And we need to do maybe in some times we will need a hybrid model. We don't need to do the switch completely. So bringing those guys to the cloud is kind of hard. So we need their expertise and work together. Another way that we are also trying to solve this problem is by making our IoT gateways and hardware actually understand more protocol. And we did a very good job actually consolidating a large list of protocols and standards. We started with the IPv6, which is key for the internet because every device can have their own IP address. This is something very important. But at the same time, IPv6 offers some other type of auto configuration that we will need later on. So this is important. Also, in the layer 2, we also consolidate very much many of the standards. And the more challenging was the application layer. This is where it's more fragmented. But still, we're partnering with some, and we're participating in some standardization bodies. And we did a very good job adapting some of them. So this is very good stack that we were building in our devices. Still, it's a lot to do because there are many of them that are not here. So how we can actually go to the internet all together if we don't have everything fully integrated and converged? So one of the solutions that we are proposing actually is going be able to host those applications and those other interfaces and standards in our gateways. So let me show you something here. We all know that the Internet of Things will be driven by a cloud model, right? This is clear. The cost, if we want to scale, the cost is a main driver. So the cloud model is the one who is working properly. However, how we can do this model if we still have those proprietary protocol or those standards very fragmented? So one of our solutions that we are proposing is actually allowing those protocols be hosted in our hardware. So in this cloud model, even though we reduce the cost, there is some challenges. Like for example, not only the integration of the legacy system, but also the computing and storage capacity is going faster than the bandwidth. So that will create a challenge, putting all the data up to the cloud to be analyzed in the cloud. And at the same time, you can think of an aeroplane. 30 minutes of flight is, I think, more than half terabytes. You cannot push all the data to the cloud to be analyzed there. Also, you will need some kind of security at the access level and some resiliency. Latency can be solved in many other ways. It can be some predictive analysis in the cloud. So latency is not a big problem, but still, in some cases, can be. So what we are proposing is actually what we call the fog computing model, and it's basically the fog computing is extending the cloud to the edge. So we complement the cloud by solving some of the challenges from the physical world at the edge level. And this is when the internet actually meets the physical world. And this is what we believe will solve many of the problems. Maybe we can call it the hybrid model that I mentioned before, where we need to wait for those legacy systems to be able to join our Internet of Things. So we're going to do step by step. One of the initiatives we are doing is bring your own interface, so our customer or partner actually can integrate inside of our hardware their communication proprietary interfaces. And also we allow them, we do some CPU cycles so they can run application on our hardware. So this is what we call fog computing. Let me show you how fog computing will solve real world problems. Here we have the city of San Francisco, and we have a person in downtown who requires some medical assistance. Normally, as an average time to get this person from an ambulance, pick it up and drop in the hospital can take 20 minutes. However, imagine that we have those IoT gateways on the ambulance, And those gateways can actually communicate with all the different devices and routers on the intersection, on the traffic attached to the traffic post. And then imagine that all of them are orchestrated as a system. So in this use case, we can actually pick up that person and drop in the hospital in less than 8 minutes. But this is not just solving a problem in one intersection. This is a system level, because if you only solve one intersection, you are creating a bottleneck in the second intersection. So we need a holistic view to orchestrate the whole system. So we actually not only satisfy the need of this person who go to the hospital and get the care that he needs, but also we avoid congestion on the city. At the same time, another use case very, very interesting is, like, for example, those trains, those freight trains. Sometimes they have some kind of a challenge on their infrastructure, and let's say, for example, that they have some displacement on the access. So between the wheels there is some distance. So we want to measure how this have been displaced, and we can do with sensor, and actually that can be reported. So this is very helpful also to measure the health of the trains and having some response. At the same time, a train is passing by the trail infrastructure every day. So there is some sensor. Actually, let me show you one of them. This is the one that I have here below. Actually tracks the motion of the train. So if the train goes by a bridge, the train can measure, actually can sense how is the difference of this bridge today respect from last year. So you can actually use the train as a sensor to monitor your infrastructure. So this is something that is very helpful for the maintenance. Here we have another sensor. It's just this measure the displacement, and we were showing this in Cisco Live a few weeks ago. But one of the use cases that I really most like is this one. Imagine this is a final train station, okay? And this train station that we have here, a train comes, like every day, but this train have a particular number on their cars, right? But in the final destination, they need to get ready for the next trip, and the next trip need to go in another direction. Sometimes some people book the train in the last minute. So if the company want to anticipate, actually, or want to organize the logistics of the organization of the cars depending on the demand, actually they need a more flexible model so they can do this. For example, this car here down is a spare car, and we have more demand of passengers. So what we do is just we add to the train, okay? So we can have more capacity of this train. But now we have a challenge with the numbers, right? How do we reorder those numbers? How we map logical view with the physical view of the train? So what we are using is our networking infrastructure, like switches, in order to identify what is the new topology of the train and in which direction the train is going to go. So I can actually order the train accordingly. This is done before, but it's done in a way that was very complicated. However, today, passengers, they are more demanding. They have their smartphone, their tablet. They want to book their seats with more flexibility. They want to have more information. So they want to have this flexibility. And train company, actually, their developer team, they want to build applications in-house. They don't want to call to the train manufacturer to let them know what they need. They want to prototype quickly. So here, the networking infrastructure, they couple from the physical infrastructure of the train and give the information to the developer and to the application level, so they can actually reorder the train and then start going. So this is actually the train that we built. This is Cisco. In Cisco Live San Francisco, we celebrate with more than 25,000 customers 2 weeks ago. We built this train model. It was very cool, actually. We have a lot of traction in the show, and you can see here 4 trains connected. And when you change one of the car and swap one of the car with another, actually the display that shows the number of the car automatically change. So we scale by using our infrastructure level and giving information to the application level. The result is we double the passenger capacity, and actually we reduce the fuel consumed because now you can accommodate more passengers on a particular train because you have one more car connected. At the same time, if you don't have the necessary passengers, you can remove one of the car in the last minute without affecting the logistics of the whole train. This is one of the use cases. You can see here another picture. Actually, this is the model when you can see inside of the train. You have the two switches. Every switch recognizes the switch connected in another train. And also you have here also the cameras. The camera also, for the person who is visualizing those cameras in a train, the order of the number of the car, the logical organization of the car is very helpful. And actually, this is displayed here on the car. Actually, you can see what are the free seats before entering the car. You know where you can sit. So this is very helpful because can allow some gamification in the train. So people like to go with their phone and be more interactive with the place. So this is one of the area that we are working. We are working with this with a large German train company for this use case, and this is very, very exciting actually. So improve the passenger experience and make easy to developer to build application is one of our key priority because we really believe if we want to make the Internet of Things grow very fast, I think it's very important for us that we open our infrastructure, we open our platform, we allow our partners, the one who really understand the business, build application on top of our infrastructure and having a very good actually system integration level. So be able to ramp up Internet of Things. So I want to conclude with a few points that we have been through this presentation. Let me show you what are the key areas. I think if you want to scale your Internet of Things and you want to accommodate IoT use cases on your existing infrastructure, I think the more important is understanding what is the business opportunity that you are going after. This is a key area. You need to understand what problem are you solving and for what use cases you want to go. Also, you want to understand what platform you want to build and what will you need. You need to use the open source, the open standard, and also who are your partners you want to work with in order to be able to understand the physical world without spending a decade to going through those physical world, physical protocols. And then finally, you need to understand what infrastructure, what flexibility you want to provide to your infrastructure, so you can actually grow quickly. You can deploy services quickly, and you can stay competitive. Because if you don't have the right infrastructure, as soon as you launch a new services, your budget actually will be consumed quickly without making any impact. So flexibility in order to capture new opportunities, because at the end of the day, every single company in the world will become in some way an IT company, because customers are demanding those gamification, customers are demanding more quality of service, and customers want to have flexibility also when they consume your product. So if your product actually, if you don't understand your customer, if you don't understand, you cannot get the data right in time and correlate with the other location, so you offer a seamless experience across different locations and different countries. So that would be hard to grow and offer this level of quality. So, but the more important, I think the step that I believe is really, really important here is actually making it easy to adopt. Any big technology that have been successful is because was deployed very quickly. So making it easy to adopt, making it easy to use, making everyone participate, I think is key for the Internet of Things actually to ramp up, and we can actually connect this 50 billion by 2020 and we can say at that time that we have new jobs and we have we have the world digitalized. We can improve our business. We can and then ultimately we can make our life better. So this is what we're looking for. In order to make it easy to adopt, I think we need to work all together: partner, customer, providers. We need to work together. We need to align. We need to converge, because today, even though we are doing a great job consolidating protocols, and also we are joining the open source, so we can get the better from the community. Even though we are doing a great job on that space, still there is a long way to go. We need to converge faster. Faster convergence in the IoT will be the key driver to make this happen. And by 2020, we can say, like we do today for the traditional internet, that our life have been changed for better. So if we work together, imagine what is possible. So thank you very much. Now
Great.
we will.
Great, thanks, Rafael. I really appreciate it. And thanks too for putting your Twitter handle up there. That's perfect. We actually didn't have any questions come in through the Q&A panel, but we have some more time here on this webinar in case anyone that is called in, if you'd like to ask a question, please go ahead and type that into the Q&A panel. We have Rafael and our panelists here. We'll give you guys a few more minutes just in case. I want to, Rafael, if you just want to go to the last slide here, I'll just do my final thanks while people they're thinking about a question they'd like to ask. I want to thank you, Rafael, and also to our panelists today. We ask that you do please complete the post-event survey once we close the event. We hope that you spend a moment to fill out those questions. You can also join us for upcoming webinars and look at our previous webinars on our website, which is go/techadvantage. And you can follow us to get the latest and greatest about our webinars at GetYourBuildOn on Twitter. Great. Okay. Well, we don't have any questions that have come in through the Q&A panel, so we'll go ahead and end the webinar here today. Thanks so much, everyone, for joining, to Rafael and to our panelists. Thanks so much, you guys. Take care, and we'll see you in the next webinar.